Welcome, all of you. I'm going to present my research on smart aging, utilization of machine learning and Internet of Things for independent living. For smart aging, what we understand by that is providing services to the older adults using the latest technologies, for example, Internet of Things, machine learning, and others. So in my research, I have focused on some of the crucial things that impacts the older adults, for example, identifying the early signs of dementia using technology like Internet of Things and machine learning. It's because dementia is one of the leading causes of death within the older adults. Also, part of my research is focusing on fall detection using wearable sensors and remote sensors, preserving the privacy because video-based fall detection can hamper the privacy of the older adults. And the focus of my research is providing smart aging services using wearable biometrics, for example, smartwatch, and identifying a person based on their ECG or PPG signals. First of all, identifying onset of dementia with Internet of Things and machine learning. That involves identifying the core components of our behavior that would indicate that cognitive decline is happening. And to identify those, we have to focus on triple R, which is reduced, regular, and repeated actions, if that happens within older adults. And these can be identifiable through the smart home environment using the sensors and the artificial intelligence. Then we can decide that, yes, there's some cognitive anomaly and doctor needs to be addressed. So our system is using public data and provided a intelligent model that will suggest if somebody needs to visit a doctor based on his action being performed. For example, everyday action like making a coffee or dusting the room. So based on those action performance, the model is going to indicate if the person is having cognitive decline. And our system has it around 90% precision using one of the classification methods. Then the second focus is on fault detection. So the system is able to identify a fall using the wearable sensor like smartwatch. It can also identify a fall using remote sensor like the infrared ray sensors. And our system can also work in multimodal way to provide even more precision on fall detection. So using remote sensor, we have achieved 97.6% accuracy to identify fall. Using multimodal, we have achieved around 99.3% accuracy. Finally, the other focus on my research was to provide a biometrics using wearable sensor like smartwatch, collecting the ECG and PPG signals. So the goal of it is to provide more secure and authenticated service from the cloud or can be personalized healthcare. The signal was collected in 3 different postures: sitting, walking, and sitting after walking. From the public data set, we have collected those signals, and our system using deep learning and Internet of Things. In single type of actions, it achieved around 100% accuracy. The rate was 0%. And when you combine with multiple types of action, for example, sitting after walking, walking or sitting, all those actions combined, that reduced the accuracy around 97.23%, and equal rate was 1.39%. So that was all in my research focus. Thanks for listening.